practical we're looking at today is called comparing the properties of two metal families. So what we're trying to do is have a look at where the metals appear on the periodic table, and then what are the properties of those particular elements, and is there a trend or a pattern that occurs as you move across the periodic table and also as you move down. Our three metals that we're going to be using today is copper, iron and magnesium. Now in a moment, the prac write-up for this particular activity will appear on the screen. What I would like you to do, please, is to pause the video, copy that down into your workbook so you have it, and then resume the video when you are ready to go. Okay, now that you've copied down the experimental write-up, let's look at the physical appearance of each of our three metals. We have copper. In copper you can see there's a very light section there where my pen is and a very dark section there. The dark section is due to the oxidation of copper in the air. So there is an oxide coating or an oxygen coating that goes onto the outside of the copper that makes it look dull. The shiny piece is what unoxidized copper actually looks like. So you can write down the physical appearance of the copper there. Underneath it here, of course, we have the iron nail, and we use an iron nail because it's relatively easy. And then we go right the way down to the bottom, where down here for Mg we have our piece of magnesium. So if you'd like to write down the physical appearance of each of those three metals, you can do that now. Now our part B test is conductivity, so in other words, does it conduct electricity? And as you can see, I have a light which is connected to a battery, and I'll place the two ends of the terminal onto the metal, and you can see that the light is illuminated, so that means that it does conduct electricity. We have a look at iron, and we find that the iron does the same thing as well. And then going all the way down to the magnesium, we've got a piece of magnesium there that we can use, and we can see that it also conducts electricity. So in effect, all of the three metals that we look at actually conduct electricity. Okay, our next experiment is looking at what happens when we add acid to them. So this is an acid reaction, and the acid that we're using down here today is our good friend hydrochloric acid. It's 2 molar, it's of reasonably high strength, and I've got our three metals. There's our copper, there is our iron, and there is our magnesium. And what we're going to do is place a dropper full into each of those. Let's start with the copper first so we can see what happens there. So we've placed it in, we give it a bit of a shake to speed the reaction up, and as you can kind of see there, not a lot happening there with the copper. It's basically sitting in the hydrochloric acid and nothing is happening. Let's then go and have a look at the iron. So we've got another iron nail there in the bottom, and we need to put a little bit in with this because the nail is actually reasonably big. Okay. So you can see there, and it's not the clearest of cameras, but what you can see is that there's a little bit of a reaction there. There's a couple of bubbles that sit around the actual iron there. So then our third metal is our magnesium. So we'll see what we can get going on with our magnesium, and as you can see there, and even here, it's vigorously bubbling, so there's a fair amount of gas being produced, and that gas that is being produced is in fact hydrogen gas. And if we were to put a match over the top of this, and after collecting the gas, what we would find is that it would do the old pop test. So you can see that it's basically bubbling. It's got a little bit hot as well in order to feel it, so that's quite a vigorous reaction there. So with our three metals, we've got a vigorous reaction with the magnesium, a little amount of a reaction with the iron, and no reaction at all with the copper. Now, the final part of our experiment is looking at the reactions with water in terms of what colour the element goes, and also what is the solubility. And what we mean by solubility is how well that it dissolves in water. We've got our old three friends of magnesium, iron and copper, but we're also adding in calcium. Now calcium appears directly below magnesium on the periodic table, so we'll be able to see whether there's any link between those. Let's start with magnesium first. You can see the powder there, because we're using powdered. Let's add a little bit of water to it, give it a bit of a shake, and you can see there that most of it's left at the bottom of, you can see there, most of it's left at the bottom of the test tube, and the water is essentially clear with that one. Let's go with calcium now. Okay, and calcium has this white powder that's at the bottom. Again, we add a little bit of water to that, and let's just get that working. Okay. Doesn't appear to dissolve too much in there, and again produces pretty much a white or a clear liquid. Here is iron now, and you can see iron is sort of a brownish, almost looks like the colour rust. Okay, again we add some water to that, and we can see there that most of it's actually dissolved into the water. Give it a bit of a shake just to get around. Most of it's actually dissolved into the water, and it gives us that brownish colour. And the final one is copper. Now copper in this case is this greenish colour. Looks a bit blue on the screen, but it's actually greenish. And we add some water to that, and again we can see the fact that it is a light blue in colour, so it's gone from green, and it's pretty much dissolved as well. So the iron and the copper seem to have high solubility, where the other two, so here's the magnesium, still has a little bit left, and the calcium has now dissolved as well. So this is the magnesium on the left side, yes, and the calcium on the right. So you can see that they have both dissolved, the magnesium not as much as the calcium, but both produce this clear liquid. Okay, now what you need to do once you've got your set of results is you need to then have a look at the periodic table, see where these elements appear, and see if you can look for patterns and trends that occur in the periodic table going across the table and also going down the table. Thank you very much.